Hello, everybody. So now we're going to be working on some word problems. All right, so interpreting negative number statements. Bruce just rode the Batmobile roller coaster. The ride climbed to its peak 75 meters above the ground. Then it dropped 95.3 meters into an underground tunnel. The following equation describes the situation, and there's your equation. 75 plus negative 95.3 equals negative 20.3. And it says, what does negative 20.3 tell us? So, folks, please don't make fun of my artwork. I really don't draw well. All right. One thing I want to point out is that this describes the situation. It's not asking, does it describe? It says the following equation describes the situation. The other thing I wanted to point out is sometimes, well, a lot of times in math, there's a lot of information in very few sentences. So it's very important to read the problem over again and possibly highlight the important points. So Bruce just rode the Batmobile roller coaster. The ride climbed to its peak, so the peak is 75 meters above the ground. Okay, that's good to know. Then it dropped 95.3 meters into an underground tunnel. Wait a minute. If it was 75 meters above the ground and then it dropped 95 meters, how can you be 75 meters above the ground and then drop 95 meters, right? 95.3 means you had to go underground. So the following equation describes the situation. 75 plus negative 95.3 is negative 20.3. So I'm going to draw a picture. All right. So here's the ground. Let's start with that. All right. That's going to be at a level of 0, a height of 0. The roller coaster goes up and then down, and it goes underground. Right. So this height up here is 75, right? And it drops, height drop from the top to the bottom is 95.3. So it's an actual drop, so it goes down 95.3, which means you end up down here, right? That's the height of the tunnel, which is negative 20.3. Right? So, what does negative 20.3 tell us? So let's look at the answer choices. The tunnel is 20.3 meters below the ground. Yeah, that makes sense. It's below the ground by 20.3 meters. The difference in elevation between the peak of the roller coaster and the tunnel is 20.3 meters. Does that make sense? That the peak, which is up here, and the tunnel, which is here, they're 23 apart. Or, sorry, 20.3 apart. No, they're 95.3 apart, right? So that doesn't make sense. And then, of course, it can't be none of the above. Let's go to the next question. All right. Negative. Sorry that the little cut off right there. Sorry about that. Daredevil Dan was cliff jumping. He jumped off a cliff that was 14.2 meters above the surface of the water. At the end of the jump, Danny was 2.3 meters below the surface of the water. The following equation describes the situation. What does negative 16.5 tell us? Well, ready? Here's the water. I think it's good to call the water a height of 0. He was on a cliff. So here's the cliff where he jumped. And I'll even draw him because, you know, that's right. I can't even draw a stick figure right. The height up here was 14.2 meters. And at the end of his jump, Danny was 2.3 meters below the surface of the water. So he ended the jump down here at negative 2.3. It says the following equation describes the situation. 14.2, the height, plus negative 16.5 equals negative 2.3. So that negative 16.5 has to be the distance from here all the way down to here. And if you think about it, well, not just the distance, it's a negative, means he went down. And it should make sense because 14.2 is to here, plus another 2.3 that he fell here, gives us a total distance that he traveled of negative 16.5, or he traveled not a negative distance, but he traveled in the down direction. So what does the negative 16.5 tell us? Which of these answer choices make sense? The distance from the top of the cliff to the surface of the water is 16.5. Does that make sense? Top of the cliff to the surface of the water? No, of course not. That's 14.2. Danny reached a depth of 16.5 meters at the end of his jump. Is that true? No, he reached a depth of 2.3 meters below the water at the end of his jump, which means the only one that makes sense is none of the above. All right, and there's one more, I believe. Here we go. Dennis let go of a penny at the top of a well, and the penny fell straight down to the bottom of the well. The top of the well was 1.5 meters above ground. The bottom of the well was 11 meters below ground. The following equation describes the situation. So, 1.5 plus negative 12.5 equals negative 11. What does the negative 12.5 tell us? All right. Once again, we need to draw a picture. Dennis let go of a penny at the top of a well. The penny fell straight down to the bottom of the well. The top of the well was 1.5 meters above the ground. So here we go. A well kind of looks like that. All right. And this is the ground over here. So that's at a level of 0. The top of the well was 1.5 meters above the ground. So this is 1.5 meters above ground. The bottom of the well was 11 meters below the ground. So down here was 11 meters below, so negative 11. Really should have labeled this M, but I haven't been labeling. Sorry about that, guys. So what does that negative 12.5 tell us? Well, if you think about it, to drop the penny, to go from the top of the well just to the ground, it travels 1.5, and then to go the rest of the way down to here, it travels a total distance of 1.5 plus the 11 it has to drop below ground. So it travels 12.5, but it drops down, so it's a negative. It goes in the negative direction, 12.5. So select all that apply. The penny fell 12.5 meters. Does that make sense? Of course it does. It fell from here all the way down, so 1.5 to get to ground level, and then another 11. So yeah, it fell 12.5. The distance between the top of the well and the bottom of the well was 12.5 meters. From the top of the well to the bottom of the well. Yep, that is 12.5 meters. And none of the above obviously can't be the answer. And I believe that is the last problem for this video. Thank you.